we're going to be doing the integration by substitution, which means I'm going to be using u and finding du and substituting the values with dx. So let us start working on our first question. Okay, so I'm given the integral of 2x minus 1 all cubed. Now, if I need to find the integral of this, I cannot find the integral of each one and then do the cubed value, so it's gonna take a lot of time from me. So the point of the integration by substitution is that I get an original function that I know how to solve. Now, what's my first step? First thing I'm gonna do is I'm going to take my u, which is the problem, which is in this case 2x minus 1. So on the side, I'm going to write u is equals to 2x minus 1. My second step is I'm going to find du, which is the derivative of this u I found here, which is going to be 2dx, because I have an x here, right? Now this is 1, this is 2. My third step is I'm going to find dx is equals to what? Because I need it here to be du. So it can all be in terms of u. So I'm going to divide by 2, so my answer is going to be du over 2. This is my first step. Step 1, I'm going to find all of these. Now, what I'm gonna do next, step 2, I am going to rewrite this as the integral of u cubed multiplied by, not dx, we found the value of dx. dx is what? Du over 2. Right? Now, if I say du over 2 is the same thing as saying 1 over 2 du. So I'm going to take my half outside. So du here, it's 1 over 2. The integration of u to the power of 3 du. Now I'm going to ignore the constant, like we said in the 4.7 video, and we're going to find the integration of u to the power of 3. It's going to become u to the power of 4 over 4. Obviously here we're going to put half. Okay, this plus c. Now, let's put like this so we can know the steps. Now, this is half multiplied by u to the power of 4 over 4 is the same thing as saying 1 over 4 u to the power of 4 plus c. Now if I multiply 1 over 2 by 1 over 4, I'm going to get 1 over 8 u to the power of 4 plus c. Now I found my final answer. Now what am I going to do? I'm going to get the value of u that I got here, which in my case is 2x minus 1, and I'm going to plug it back into the u here. So I'm going to get 1 over 8 into 2x minus 1 to the power of 4 plus c, and this is my final answer. Okay, now I have my new integral. It's integral of the root 3 minus 2x. Now I'm going to take what's under the radical as my u, so we're gonna do this on the side. So u is equals to 3 minus 2x. I'm going to find then the derivative of u, which is negative 2, the derivative of this function, dx. And then I need to find my dx, which is just always du over whatever's next to the dx. So du over negative 2. Now let's go back to my equation. The integral of radical u multiplied by, we found dx to be what? Du over negative 2. Now this is the same thing as saying 1 over negative 2 du. So I'm going to take negative 1 over 2 outside, radical u du. We don't have to write the multiplication. Okay, now I'm going to integrate. This is the same thing as saying, I'm gonna keep the negative half outside. The integral of u to the power of half du. So let's start solving it. Negative 1 over 2 u. U to the power of half plus 1 gives me 3 over 2 divided by 3 over 2 plus c. Now, after I do this, I'm going to do, like remember we said in 4.7, negative 1 over 2 multiplied by 1 divided, this is 1, right? So 1 divided by 3 over 2 is the reciprocal, which is 2 over 3. Or you can just do it on the calculator, 1 divided by 3 over 2 if you're unsure. U to the power of 3 over 2 plus c. Now I'm going to multiply negative half by 2 over 3, which is going to give me negative 1 over 3. Now the u, I'm going to substitute what I took as u here. So it's 3 minus 2x, so I'm going to put 3 minus 2x to the power of 3 over 2 plus c. This can be my final answer. or I can do negative 1 over 3 into 3, no, to the radical. Now we know this is up is the power inside, 3 minus 2x all cubed and to the second root plus c. And this would be my final answer. Okay, now here we might have a problem in choosing our u. How do I know which value of u I'm going to take? Now if I look at the equation here, I'm going to take the original function which I can find its derivative here. So let's take for example here tangent x. Its derivative is what? Secant squared x. So I'm going to take the tangent squared x as my u, but I'm only going to take tangent x, not with the squared, because then it would make things more complicated for me. So I'm going to take u is equals to tangent x. I'm going to get my du. What's the derivative of tangent? Secant squared x dx. Then my dx is what? Always it's du over whatever is next to the dx, secant squared x. Now, why is it very important for me to know which value of u I'm going to choose? Now, if I go back here and I'm going to put my integration again, this is going to be u squared secant squared x multiplied by my dx, we found it to be du over secant squared. Now this I'm going to see why it's very important for me to know which value of u to choose. Now, this secant squared is going to cancel with the secant squared, which is going to make the solving so much easier for me. So it's only going to be integral of u squared du. Now I'm just going to solve it normally. U to the power of 3 over 3 plus c. Right? Now I'm going to get my value of u, which we found to be tan x cubed or tan over 3 plus c, and this is my final answer. So it's very important for me to know which value of u I'm going to choose. So the one whose derivative I can find in the equation, I'm going to choose it. Yani here the original function, here the derivative is in my equation. I don't know if that makes sense. It's gonna make more sense when we solve more of these questions. Okay, so this is my new integration. I have 2x to the power of 3 over radical 1 minus x to the power 4 dx. Now let's think about how I'm going to choose my u. If I look at x to the power of 4 here, or the whole function, this one, the one down, 1 minus x to the power of 4, I can find its derivative to be up, right? X to the power of 3. How do I know? 1 minus, okay, 1 minus x to the power of 4, its derivative is what? Negative 4x to the power of 3. So x to the power of 3 and x to the power of 3, they can cancel. So this is how I know which value of u I'm going to choose. So I'm going to choose u to be 1 minus x to the power of 4. Then I'm going to find my du, which is its derivative, negative 4x to the power of 3 dx. Then I'm going to find my dx, which is du over negative 4x to the power of 3. It's very useful because then I'm going to get to cancel it and I'm going to make my life easier. So let us rewrite this. It's going to be the integration of 2x cubed over radical u multiplied by du over negative 4x to the power of 3. Now this is going to cancel with this. What am I going to get? Integral 1 over radical u multiplied by du over negative 2. Now, as we said before, this is 1 over negative 2, so I can take it outside. So negative 1 over 2 integral 1 over radical u du. Now, we're gonna solve the integration normally. This is the same thing as saying negative half integral u to the power of negative half du. Now let me solve my integration. It's going to give me u to the power of, obviously don't forget negative 1 over 2, into u to the power of half over half du. Because I did here negative 1 over 2 plus 1 for the integration. Then negative 1 over 2 multiplied by 1 divided by 1 over 2 is going to give me 2 u to the power of half plus c. No, here it's wrong. It should not be du, it should be plus c. Plus c. Okay, then what am I going to get? This is going to be negative 2 over 2, which is just negative u to the power of half plus c. Then I'm going to get the value I chose as my u, and I'm going to substitute it back down. So negative radical 1 minus x to the power of 4 plus c is going to be my final answer. So here I have my new equation. I have the integration of x cubed plus x all to the power of 5 into 3x squared plus 1. Now how am I going to choose my u? I have x cubed plus x, and then here I have 3x squared. The derivative of x cubed plus x is going to be 3x squared plus 1, right? So we can cancel them. So this is the value I'm going to take as my u. 1 to the power of 5 is harder, so I'm going to take its value as u if you don't really know how to choose the u. So x cubed plus x, my du is going to be 3x squared plus 1 dx. Then I'm going to find my dx, which is just du over whatever is next to the dx, 3x squared plus 1. Now I'm going to rewrite this, u to the power of 5 into 3x squared plus 1 multiplied by, we found dx to be what? Du over 3x squared plus 1. Now my 3x squared plus 1 and 3x squared plus 1 are going to cancel, so I'm going to be left with integral u to the power of 5 du. Now let me solve. I'm going to get u to the power of 6 over 6 plus c, and then I'm just going to put the value of u back, which is going to give me x cubed plus x all to the power of 6 over 6 plus c, and this is going to be my final answer. Here's my new question. I have the integral of x squared cosine x cubed. Now, if I look at this carefully, I need something I can cancel, right? Something where I can find its derivative in the equation. If I look here at x squared, for example, its derivative is 2x. Can I find 2x anywhere here? No. Let's say I take x cubed. It's going to be 3x squared. Can I find x squared here? Yes, I can. So I'm going to take x cubed as my u. Now, some people might probably ask, why do I not take cosine x cubed? If I do take cosine x cubed and find its derivative, I'm going to have sine and stuff, and we don't have anything to cancel it with. So I'm only going to take my x cubed to be my u. So let's put this aside. U is equals to x cubed. My du is going to be 3x squared dx. And then I'm going to find my dx, which is du over 3x squared. Let me rewrite my integration. The integral of x squared cosine u multiplied by dx, which is what? Du over 3x squared. X squared and x squared are going to cancel. Now I have du over 3, which is the same thing as saying 1 over 3 du. So I'm going to take the 1 over 3 outside. Cosine u du. Now, the integration of cosine is sine. So I'm going to take 1 over 3 sine u plus c. Here I integrated. Now I'm going to take the value of u that I took up, which was what? X cubed, right? So 1 over 3 sine x cubed plus c, and that's my final answer. Okay, so now we're going to be solving the same concept, but there's only one additional thing, which are my limits. Now, first let's do the first step we usually do, is finding my u. If I take x to the power of 3, for example, the derivative is going to be 3x squared. I don't have x squared, so I cannot cancel it anywhere. Now, if I take x to the power of 4, it's going to be 4x to the power of 3, and I have an x to the power of 3, so I'm going to take this as my u. So u is equals to x to the power of 4 plus x to the power of 4 plus 9. Yeah, and then my du is going to be 4x cubed dx, and my dx is going to be du over 4x cubed. Now this is, like we said, always the first step, but now we have a new step because we have a limit. When we are using u, we don't have the same limits. We need to find a new limit. So let's find my new upper limit and my new lower limit. My new upper limit is basically just getting the upper limit here 1 and substituting it into u. So 1 to the power of 4 plus 9, and this is going to be 0 to the power of 4 plus 9, which is going to give me 10 and 9. So these are my new limits. So now when I rewrite my integration, I'm going to have 10, 9, x to the power of 3 over radical u multiplied by my dx is what, du over 4 x to the power of 3. Now I know my x to the power of 3 and 4x to the power of 3 are going to cancel. I'm going to be left with the integral from 10, 9, 1 over radical u. This is the same thing as saying 1 over 4 du, so I'm going to take the 1 over 4 outside. Okay, again, this is the same thing as saying 10, 9, u to the power of negative half du. Since this is down, I'm going to take it up, and now I am going to integrate. I'm going to get 1 over 4 into u to the power of half over half plus c. Now if I'm going to rewrite this, it's the same thing as saying 1 over 4 multiplied by, don't forget this is 1 divided by 1 over 2, so it's going to give me 2. U to the power of half plus c. 2 over 4 is just half, and then u to the power of half is radical u. So half radical u plus c. But this is not my final answer. Now the thing that differs here is that I am not going to substitute my u value back in, because if you remember, so this is obviously going to be from 10 to 9, and wait, there are no c's here because it's definite. Whenever I have a limit, there are no c's. So this is going to be from 10 to 9. So this is my mistake, 10 to 9. Okay, now I'm going to substitute directly into u. So I'm going to take half outside into radical 10 minus radical 9, which is going to give me negative 3 plus radical 10 over 2, which is equals to 0.0811. Now when you have the limits, you can put this directly into the calculator and you'll get your final answer. You just have to show until here. But then to get this, so if you don't want to make mistakes, just plug this one into the calculator, not the new function, this one. Okay, so my new integration is sine cubed x minus 2 cosine x minus 2. Now I need to find my u. My u here, what is the original, let's say the original function. So here I have the derivative of sine is cosine, right? So I can cancel cosine. So I'm going to take sine as my u, so sine x minus 2, but without the cubed. Then I'm going to find the derivative of sine, which is cosine x minus 2 dx, and then I'm going to find my dx by just doing du over whatever's next to the dx, which is cosine x minus 2. Now let me substitute back into my equation. This is going to be u cubed multiplied by cosine x minus 2, and we have my dx, which is what, du over cosine x minus 2. So my cosine x minus 2 and cosine x minus 2, they're going to cancel. So I'm going to be left with the integral of y cubed du. Let me just integrate this. It's going to become u to the power of 4 over 4 plus c. Now I'm just going to get my original function in, which is sine x minus 2, so I'm going to take sine 4 x minus 2 over 4 plus c, and this is going to be my final answer. Okay, so this is going to be our last question. Now, like we said here we have the limits. So let us solve normally first by finding my u value. If I take x cubed plus 1, my derivative is going to be 3x squared, and I have 3x squared here, so I'm going to choose this, so because I can cancel. U is equals to x cubed plus 1. My du is going to be 3x squared dx, and my dx is going to be du over 3x squared. Now I'm going to find my new upper limit and my new lower limit by substituting these into my u. So I'm gonna have 1 cubed plus 1, and I'm going to have negative 1 cubed plus 1. This is going to give me 2, and this is going to give me 0, so these are my new limits. So I'm going to have 2, 0, 3x squared multiplied by radical u, and then my dx, which is du over 3x squared. 3x squared is going to cancel with 3x squared, so I'm going to be left with the integration from 2 to 0, radical u du, which is the same thing as saying u to the power of half du. Now let me find my integration. I'm going to get u to the power of 3 over 2 divided by 3 over 2. Now there is no plus c because I have my limits, so from 2 to 0. 1 divided by 3 over 2, like we said before, it's 2 over 3, u to the power of 3 over 2. Now we're going to take the 2 over 3 outside. Okay, so I'm going to take the 2 over 3 outside and then into radical the 2 cubed minus radical 0 cubed, which is the same thing as saying 2 over 3 into radical 8 minus radical 0. After I put this into the calculator, I get 4 radical 2 over 3, which is equals to 1.89. Now if you're unsure of your calculations, just make sure you reach like this step maybe, and then to be sure of your final answer, just plug the original function into the calculator and you will get your answer.